Alright, so now we will learn about a fascinating data structure known as the queue. Imagine a ticket queue outside a cinema hall where people stand in a line and the first person to enter the queue is the first one to get the ticket. That's precisely how a queue works. Now, let's talk about four types of different queues. Simple queue. It's the basic type of the queue we just discussed. Elements are added at the rear and removed from the front, allowing the first in first out FIFO principle. Circular queue. This type of queue is like a variation of the simple queue. When the rear reaches the end of the queue, it wraps around to the beginning, allowing us to reuse empty spaces efficiently. Priority queue. Unlike a simple queue, a priority queue assigns a priority to each element. The element with the highest priority gets dequeued first, regardless of its position in the queue. Double-ended queue. Also known as dequeue, this type of queues allow us to insert and remove elements from both ends. It offers more flexibility in managing elements compared to other types of queues. So, these different types of queues have their unique features and use cases. Understanding them will help you become proficient in choosing the right queue for specific programming problems. So, let's dive in and explore the world of queues. In a simple queue, we have a straightforward way of doing things. When we add an element, we do it at the rear of the queue, and when we remove an element, it comes out from the front. It's like standing in a line to get something, and the first person who entered the line gets served first. So, this is known as the FIFO rule, which stands for first in, first out. So, the element that got in first will be the first one to get out. It's a simple and organized way of managing our data. And now let's explore the circular queue. In a circular queue, we make a special kind of connection between the last element and the first element, creating a circular link. So this means that after the last element, the next element in the first element, and the cycle continues. Now, one of the main advantages of a circular queue over a simple queue is that it offers better memory utilization. You see, in a simple queue, when the last position is full and the first position is empty, we cannot insert any more elements at the beginning, right? But in a circular queue, since it forms a circle, we can insert an element in the first position even if the last position is full. This gives us more flexibility in managing our data and make it more efficient in terms of memory usage. It's a clever way to make the most out of our queue. And now, let's discuss the intriguing concept of priority queue. In a priority queue, each element is not just an ordinary element, but it also comes with a priority assigned to it. This priority determines how the elements are served in the queue. The element with the highest priority gets served first, and if there are multiple elements with same priority, they are served based on the order in which they arrived. So, when we insert elements into a priority queue, we consider the order of their arrival. However, when it comes to removing elements, we pay attention to their priorities. The element with the highest priority will be the first one to be removed from the queue. This makes the priority queue a very powerful and versatile data structure as it allows us to handle items based on their significance and importance. It's like giving VIP treatments to some of the most important elements in our queue, right? Now, let's explore the fascinating world of the double-ended queue, often known as dequeue. Unlike the other queues we have discussed so far, the dequeue is unique because it allows us to perform both insertion and removal of elements not only from the front but also from the rear as well. Picture it like this. Imagine you have a queue with two ends, one at the front and the other at the rear. This special feature means that the dequeue does not strictly follow the traditional FIFO rule like the simple queue does. Because of its flexibility, the dequeue is an incredibly versatile data structure. It allows us to efficiently add and remove elements from both ends, making it suitable for various scenarios and problem solving situations. Whether we need to add something important at the front or remove something from the rear, the DQ has got us covered.